Hey, what's up YouTube? I'm back again with another math lesson, and today we'll be talking about the chain rule, a very important rule and something that is a little bit more difficult to understand. And this requires that you know derivatives to a very high extent. So let's talk about what this sign here means, or what this fraction here means, what this derivative means. So y represents basically the function, right? Y could be any function f of x, as I'll write over here. Y could be any function of x. Now, this is with respect to d of x, so the variable that has to be in this function is x, right? So, for example, let's say f of x was just x squared. What you want is the change of x squared over the change in x. And that's very simple. You would just use the power rule and you get 2x. However, a lot of the time, this variable over here, this with respect to x, this isn't just x, it's another function. So let's take, for example, if you want the change with respect to x of x squared plus 1 squared. Now, we can't use the power rule because this over here is x squared plus 1, not x. So what we're going to do is we're going to split it up. And before we do that, we'll just have to review a little something basic about fractions, right? So let's say you have the fraction 2 over 5. I'm going to split this up and multiply it by something, right? 2 over something multiplied by something over 5. The point is, literally anything can go here. And I'm just going to say u. They are equal to each other because the u's will just cancel out. Now this will be very important to derivatives because what we're going to do is we're going to split this dy over dx into two fractions. We're going to split it up into dy with respect to du multiplied by du with respect to dx. And we're going to say that this u over here is this inner function over here, x squared plus 1. So, knowing that that's the case, we're going to take dy with respect to du. If this is u, then we could just use the power rule. So it'd be 2 times u, because this is just u squared. And then we multiply that by du over dx. So, the derivative of this inner function, and that'll just be 2x. But obviously I can't leave this u here, so I'm going to finally write the final answer, which is 2 times x squared plus 1 times 2x. Or, if you want to simplify it even further, 4x times x squared plus 1, or 4x cubed plus 4. 4x, my bad. So that is essentially what the chain rule is. But let's take another example, or try and understand it in a different way. What you do is you start off with the outermost function and you keep taking the derivative of the innermost functions until you get to x, or the variable that you're trying to find this with respect to. So let's take, for example, let's try and erase it a little bit more quickly. The next example that I'm going to be showing you is going to be a cosine of x squared. So, here, let's just erase this over here. Cool. So, here, cosine of x squared. We want to find the derivative of this. So, in the same way, we're going to treat this as a u function. So, the derivative of cosine is just negative sine of this variable here, which is u, or x squared. But then we multiply it by the derivative of the inner function, du with respect to dx, and then that will just be 2x. So our final answer is negative 2x sine x squared. Cool. Now, we're just going to do one more example so that something a little bit more complicated, so you guys kind of get the gist of it. Alright, we're going to take the natural log of e to the x squared. We're trying to find the derivative of this with respect to dx. So what we have is ln of e to the x squared. So we're going to treat this as some variable v, right? So this will just be equal to dv or dy, right? Because this entire function is y over dv multiplied by dv over dx. But before I do that, this is x squared, so we're going to treat this as u. So x squared is u, and v is e to the x squared. So we're going to split this up again into dv over du multiplied by du over dx. So the derivative of y with respect to v, it's ln, so it's just going to be 1 over e to the x squared. And then dv over du will just be the derivative of e to the x squared, and that's just going to be e to the x squared. And then we have du over dx, so the derivative of x squared, and that'll just be 2x. What we notice is that these cancel out, so our final answer is just 2x, which is really simple. And that's basically what the chain rule is. It's about mastering how to split these up into multiple derivatives and recognizing that you want to take the derivative of the outer function and keep going inward until you reach that x, right? Because the outermost function is ln, then it's e, and then it's this exponent up here, x squared. I hope you enjoyed this video and hope you join me tomorrow when we cover more things about derivatives, differentiability, and continuity. I'll see you tomorrow. Thank you and goodbye.